Now that we know the basic understanding of linked list and how the singly linked list will actually look like, let's just get started with the implementation of singly linked list by setting up the structure for implementing the node that we have in the singly linked list implementation. Basically, singly linked list is nothing but collection of nodes, right, in which each and every node is connected to the next node. That basically means that in whatever the singly linked list that you see on the screen, right, this is one node, code is another node, true is another node. Likewise, each and every value is a node in which it has the value and it also has the connection to the next node that it is connected to. When it comes to the tail node, right, which is nothing but the last node that we have in the singly linked list, it is not connected to any other node. After observing this singly linked list, any node that you define in the singly linked list basically should have two functionalities. One is to store the value that user wants to store as part of that node, and the second functionality is to store the reference for the next node that it is connected to. Okay, using this next node we will be able to go on to the next node. As a result, we will be able to reach till very last value we have in the case of singly linked list implementation. That's the reason why keeping track of this next reference is absolutely important in the case of singly linked list or any type of linked list implementation. So we have to make sure that whatever the node structure that we are defining has the capabilities to store the value and also store the reference for the next node. Okay, one thing that you have to remember here is, since singly linked list is a heterogeneous data structure, we should support all type of data storage. That basically means that I may want to use some numeric value, I may want to use some boolean value or some other floating value as well. Okay, so ultimately whatever the type of value that I want to store in a specific node, basically each and every node should support that heterogeneous data storage as well. Okay, so that is something that is very important once again as part of value functionality on a singly linked list node. So out of the box, no programming language will basically provide us this kind of structure, right? So we have to write our own class to represent the node that we have in the case of singly linked list. So for that, what we will do is we will basically define a class called node. Okay, in this class called node, basically we need two things. One is value and the other is reference to the next node. That's the reason why we will define two variables called value and another variable called next. Here value variable is basically used for storing the value of the particular node, and next is basically used for storing the reference of the next node that particular node is connected to. Okay, so this is the structure that we will be defining. But in my singly linked list implementation, right, I keep on adding more and more values onto my singly linked list. That basically means that I will keep on adding more and more nodes onto my singly linked list. At that time, basically whenever I create the object of this node class, I am going to assume that I will not worry about this next condition, but based on the functionality that I will implement. Like I mentioned, we will be implementing push, pop, shift, unshift, various other sorts of implementations, right? So I will basically worry about adjusting this next pointer, basically reference of the next node in those specific functionalities. But when I create the object of this node class, I will only worry about taking the value from the user and storing that value as part of this node. For that, basically what I will do is I will create a constructor. So this whatever the constructor that I'm going to define, it will basically take the value from the user, and whatever the value that user passes, it immediately assigns to this variable. So immediately we will define a variable, value variable that we have, right? We will add whatever the value that we get to this specific variable. As I mentioned, at this point of time I will not worry about adding the next node, right? That's the reason why whatever the next that I have, I will simply assign null to this. Okay, once again I'm mentioning, when I go ahead and implement the respective functionality, I will make sure that I'm assigning the appropriate next node from the node that I'm adding at that functionality implementation. So don't worry about this at this point of time. Basically when I implement those functionality, you will basically understand how these next is getting assigned with the appropriate next node. Okay, so only thing that we have to worry here is we will define a class. In this class basically we have two variables, one is value and the other is next, and to add the value into the node object we basically added one constructor which takes the value and simply assigns that value to whatever the value variable that we have. Okay, so that is the structure of singly linked list node class. Now that we know this, let's go ahead and let's try to implement it. Okay, since it is our first singly linked list related implementation, right? For that, what I want to do is like how we have done in the case of searching and sorting, we will be creating a separate folder for organizing all the singly linked list related implementation. For that, inside our project, whatever we are keeping track of in that project, let me just create a new folder called singly linked lists. Okay, inside this class what I will do is I will simply create one file called node.cpp. okay, in this file we will be writing the node class that we will be reusing when we implement the singly linked list or any other data structure in the future videos. Okay, so now let me just minimize the side nav, and here let me just import the basic boilerplate code that we would be needing. Okay, now here let's write the class for this node according to the structure that we have discussed previously. So let's write a class, let's name the class as node. Now let's define the variables that we would be needing as part of the each and every node that we have in the singly linked list. So any node that you take in the case of singly linked list, right, we need to have two values. One is a value that is actually stored in that specific node, and the other one is to store the reference of the next node from that current node that we are at that point of time. So we need two variables to represent these two values. So here in the beginning, let's just assume the type of the value that we are trying to store is integer, and let's define one variable called value with that integer type. At this point of time, don't worry how we are going to make this node class support heterogeneous data, but for now let's just try to concentrate on the variables that we would be needing inside the node class. Once this is done, I will try to show you what are the modifications that we can do such that it will basically support the type of the data according to the user's given requirement. Okay, along with this value, what we would be needing another variable to store the reference of the next node, right? Using that next node, we will be able to go on to the next node. From that next node's next, we will be able to move on to the further nodes we have in the singly linked list. So that is again of type node, right? That's the reason why what we will do is we will define the reference of next here like this. Okay, so remember that the type of the node, again the reference that we are storing as part of the next is nothing but of type node. That's the reason why type I have given is like this. Okay, now what we need to do, whenever user wants to add some value into the singly linked list, right, user will be creating the object of this node class. So at that point of time, user will be passing the value to this node class. Okay, so to support that object creation, what we will do is we will basically add the constructor. So here let's define that constructor. In the beginning, we assumed the data that we can store in this node is of type integer only, right? So obviously in the constructor also the variable type that we need to take is integer only. Now inside this constructor, what we will do is we will simply assign the value that user has passed to the value variable that we have declared inside the node class. So this dot value equal to value, and at this point of time, let's not worry about the next node that we have from the node that we are trying to process. Remember that when we implement the certain functionalities on the singly linked list, be it adding new nodes or removing the nodes, at that point of time, I will show you how can we assign the appropriate next node reference to the next variable that we have here. But at this point of time, the next we will be initializing it with null. Okay, remember that is how we will be doing. Okay, this next is basically assigned with appropriate next node when we implement the certain functionalities in the singly linked list. Okay, just don't worry about that at this point of time. I will make sure that you will understand this thing when we implement the singly linked list and specific functionalities in the singly linked list. Okay, So that's it about the structure of the singly linked list node. Now we have to add a semicolon here to close the class structure. Now let's just try to define the object of this node class, and let's just try to assign some values, and let's print them to confirm the you know uh, object creation of the node class. Now here, to do that, let's just do node star, let's just say new node equal to new node of, let's just say I want to pass the value 10. Okay, now what we can do, we can, on this new node object that we have got, internally we have the value and we have the reference of the next node, so we can simply print them, right? So let's do cout, okay, new node dot value, let's just do end line. Okay, similarly let's just try to add one more node object. In this node, let's just try to store the value 20. Okay, here instead of new node, let's just use the variable new node 2. Okay, this let's just use new node 1. Okay, now if I execute this, let's see, ideally we should see 10 and 20 printing on the console. Okay, so that is what we have got. 110 is from the new node 1 object, and the other 20 is from the new node 2 object. But the problem here is, internally in whatever the node class that we have defined here, right, we are able to store only integer values. Why? Because whatever the data type of the value variable that we have declared inside the node class is of type integer. That's the reason why we are only able to store the integer values in it. But if I want to store the strings or floating point numbers or booleans or any other data type of data, if I want to store as part of this node, it is not possible at this point of time. So to support that, what we will do is, we should have some sort of functionality to define the data type when we actually create the object of this node class, so that automatically the value will become of type that we are passing. For that, what we will do is, we will take the help of template keyword that we have in the C++. So for that, what we will do is, in the class that we have defined, above that class definition, we will simply add template. Let's just say this will accept all the types T. Okay, this type T is something that we will mention when we create the object of this node class. Okay, that means if at all, if I want to store the integer, I will mention node of type integer. If I want to use strings, I will mention node of type string, such that whatever the value that I am passing, automatically it gets converted to that type. As a result, here whatever the data type int that we have mentioned, right, this we can simply modify it to type, because as I mentioned, when we create the object, we will pass this T. How we will pass that T, I will show you in a couple of minutes when we complete it, when we complete the modifications that we are discussing here. Anyway, the next object reference will remain same, and when we create the object of the node class, there also we will be passing the type of the value. Okay, so the int value whatever we have defined while declaring the constructor, that also should be modified to the type that we have defined using the template keyword. Okay, now if you see here, we are seeing issues in the previously existing code. Why? Because when we created the object of this new node 1, new node 2, we have not specifically mentioned the type of the data that we are trying to pass to this node object creation. That's the reason why we are seeing issue. To pass the type, here we are passing the integer value, right? We need to explicitly tell that constructor, basically we are passing the integer values. How we will mention that is, in before whatever the class object that we are trying to create, here it is node class, right? Here what we will do is, I will simply pass int here. Similarly, I need to mention the same thing here as well. So this basically means that, I am trying to create the node object, but internally the type of the data that I want to store is integer. As a result, the value variable whatever we have declared, that data type will be of type integer. As a result, the constructor whatever we have declared also will accept integer, and whatever the value that we are passing will get assigned to the value variable that we are declaring. In such way, we are trying to make this node class generic such that it will accept the values based on the data type that we are passing at the time of object creation. That is a very important thing that you need to remember. Now, similarly for the second node object also, let's just try to define the type integer only, because here also we are passing the integer values only, right? So let's just exclusively mention node type int. As a result, the second error, whatever we were seeing on the Visual Studio Code, that also got disappeared. Now we can run this code absolutely fine, and we should be able to see 10 and 20 printed on the console. See, 10 and 20 got printed. For example, in the case of new node2 object, I don't want to pass the integer value. Rather, I want to pass the string value. For that, what I can do is I can simply pass string as an argument here rather than passing the integer. Now, this object will basically expect a string value to be passed in the argument. That's the reason why if you see here, there is an error coming. What it is saying, no instance of constructor, it is expecting string. As a result, we are seeing the exception. Now, what we can do is we can simply pass some string. Let's just say the string that I want to pass is coding pal. Okay, so now the error got disappeared. If I run it now, as part of the new node 1 value, we should get 10. As part of the new node 2 value, we should get coding pal printed on the console. So let's just do run code and see 10 and coding pal got printed on the console. If at all, if you want to, create one more node object with some boolean data or something. So here all we need to do is modify the type to boolean. Here also let's just modify it to bool, and let's just pass some true or false, whatever the boolean value that we want to store. Here let's just modify the variable name to node3, and let's just modify the variable in the print statement also to node3, and let's just run it now. If you see here, 10 coding pal and true, which is nothing but 1, got printed on the console. In that way, by specifying the template here, we are making the node class generic to accept the any type of data based on user's requirement at the time of object creation. In such way, we are basically supporting the heterogeneous data in the node class that we have defined here. Okay, so that is a very important thing that you need to remember. If you simply make the type of the value variable that we have declared inside the node class as integer or string or boolean or anything, it will only be able to store that specific type of the values. But here we want to support the generic data. That's the reason why we are specifically mentioning the template of the node class that we are defining, such that the type of the data that we want to store will be passed at the time of object creation. Okay, so that is very important thing. Now the node class creation is perfectly fine and it is done. Now one more thing that we need to remember is, while implementing the singly linked list, we need to import this class and we should be able to reuse it. For that importing, what we need to do is we basically need to create the header file, right? For that, what we will do is we will simply copy the entire code without the main method, and here inside the singly linked list folder, whatever we have created, right? Here what we will do is, let's just create one header file called node.h. Okay, now all we do is we will simply paste that code into this header file that we have created here. That's all. Okay, since we need to have a support to import the node class that we have written in wherever, maybe while implementing the set data structure, or stack or queue, any other data structure, we should be able to import it and we should be able to reuse it according to our need. That's the reason why we have created a separate header file with the logic that we have written without main method, and we have written into this header file. Okay, so that is the structure of the node class that we have for the singly linked list. Okay, so that's all for this one. In the next videos, let's get started with setting up the basic singly linked list such that we can implement all the functionalities that we have for singly linked list data structure.